Okay, talking shifters of demand. In part one, you saw 5 of those factors. Here we got 2 more to make a total of 7. Back on page 43 of your textbook, you'll notice a change in the price or availability of substitutes. Substitutes, one thing or the other. Fried chicken, pork ribs, spare ribs. Holy cow, I think I'm hungry. Spare ribs, fried chicken. I mean, really, I don't know what's better. Steak, too, I guess, but we're keeping it simple. So here's chicken, fried chicken, KFC, Popeyes, whatever. For grins and chuckles, for some crazy reason, the price of fried chicken as a general whole has dropped. So here we have a change in price of an alternative good. This is not the demand curve we're thinking about. This is the demand curve. But it's a related good, a substitute, and the price has fallen. For some reason, there's a sale or something, and the price has fallen for fried chicken. You'll notice that the fried chicken has fallen in price. People are going to buy more of it because of diminishing marginal utility, etc., opportunity cost, we have talked in other parts. So now we have a lower price, people are buying more of it. Because people are buying more of fried chicken, what does that do to the demand for ribs? Notice the price of ribs hasn't changed. If people are buying more chicken, are they going to buy more ribs or less ribs? May I point out they are substitutes. Right. They buy fewer ribs. So the demand curve itself will shift to the left for ribs. In other words, even though the price hasn't changed, people are going to buy fewer ribs because they're buying more chicken instead. So the demand curve shifted to the left, and at the original price, we'll notice that there is less being bought. The quantity demanded has reduced. Demand itself shifted left. There is literally less demand for ribs because of a change in the price of something else related to it, a substitute. Again, page 43 of your textbook. I'd like to point out that in a substitute situation, notice what the QDs, if you were to graph both, you don't, you only should have to graph this one, but if you were to graph both, notice that the QDs move in opposite directions. See, in the opposite directions? Because if one increases the substitute, you're going to use more of it and less of that. Just flip it around. What if the price of chicken were to go up? And that would result in a reduction in the quantity demanded of fried chicken. People would buy less of it because the price went up. Yeah, I know this is crazy. I'm at home controlling my computer at school and then recording it back home for you. If this were to happen, the demand for spare ribs would actually increase and go to the right because they go in opposite directions. Let's take a look over here now. These are complementary goods. Complementary means they go together. Like love and marriage, like a baby and carriage, or however that song goes. So a complementary, they go together. What's going to happen to the price of milk? Did you say sale? Good. With this lockdown, dairy farmers are literally pouring tens and tens of thousands of gallons of milk away. They're just throwing it away. You see, you're not at school. Guess what school has a big demand for? That's right, milk. Schools use a lot of milk. Schools are not open. Well, mommy and daddy who buy groceries don't buy as much milk as they might otherwise. So there is less milk being bought and sold. So long story short, we'll see here as we get to chapter 5, the market. The price has fallen, therefore, people may actually buy more milk at the store. In fact, I went to Dick's Market. I noticed that the price of milk to me, appears to be cheaper than what it has been before. Instead of the $3 plus, it's closer to $2 now. Even Meijer, I think, had some sale on milk. Well, if the price of milk goes down, People are going to buy more of it. Notice the demand curve did not change. Price did. QD did. That's a Q. That's a Q. But, yeah, nice. QD did not change. Excuse me. Demand did not change. QD did. It got bigger because there was less of it. Notice there's a negative relationship. If this becomes less, this will become more. If this becomes more, that'll become less. But the demand does not change. What does this have to do with Frosted Flakes? Because Frosted Flakes, you all know, they're great. You gotta love them. You eat them up. Thank God for Mr. Kellogg and mold and a serendipitous overnight leaving it out on the counter. Yeah, you should check it out. Quite a story. Not the drunk history Mr. Oberman wants you to watch. Just the regular one. It's pretty cool. Okay, so people are buying more milk. What will happen to Frosted Flakes? Will people want more Frosted Flakes or less Frosted Flakes, everything else being equal? In other words, the price of Frosted Flakes, we're not going to change it. We're just thinking, how does the change in the price of milk and people buying more of it, how does that impact Frosted Flakes? Yep, people are going to buy more Frosted Flakes, everything else being equal. In other words, the demand itself is going to shift to the right because more people now are going to buy Frosted Flakes than bought them before. Because milk is cheap, therefore the Frosted Flakes milk combo overall is cheaper. Remember that budget line we looked at before? It's as if the budget line shifted to the right or in effect rotated to the right. So the QD2 is larger. These are complements. They go together. So notice when this QD went away from 0, because 0 is here at the corner, just like there's a 0 here in this corner, QD went away from 0, so too shall this QD go away from 0. This one moved because of a change in price, moved you along the demand curve from here to there. It moved you down the demand curve. This demand curve itself changed because we're not going to let price change. We're letting an alternative relationship, an alternative good or service. In this case, one that goes with, they go together. So guess what the QDs do? They go together. If one increases, so shall the other. Ladies and gentlemen, we have just looked at the 7 shifters of demand. And for those of you listening to me, may I point out your homework? On Google Classroom, I gave you homework. It was chapter 3 on page, oh golly, I'm looking at it now. Page 25. If you look at page 25, you'll notice, okay, I found page 25. Here we are. It looks kind of like this. I'd like to point out you might want to use a different sheet of paper. They, for some crazy reason, have the columns switched around to make sense. Look at column 1. This is the event. This is the thing that happens, all right? Hang on, let me see if I can do this for us. Oh, that's pretty not cool. Let's make it bigger, shall we? Yeah, this is just loving it every time. So we size this puppy. Let's go 200. And then we go full screen. Okay, good. This is better. This is an event. This is not the demand curve you're graphing. This is the demand curve you want to look at. For example, the demand curve for hamburger. What happens to the demand curve for hamburger if the price of steak increases? Wow, sounds like what we were talking about just moments ago. Well, over here, they're telling you the relationship is substitute. If it's a substitute relationship, maybe, just maybe, this comes to mind, right? Notice that they go in opposite directions. Let me clean this up a little bit. Good. Notice they go in opposite directions, right? So this would be hamburger, this would be steak. That's what we're talking about. So we get back over here. So what happens to the demand for hamburger if the price of steak increases? I would like you to graph in this little itty teeny tiny rectangle. Actually, you want a separate sheet of paper. Maybe you could do it bigger and better on that. I want you to do, on this number 3 demand shift, I want you to demonstrate something like this. P, a Q, a down D, D1. Title, an arbitrary P1 over to QD1. And then you're going to increase or decrease demand. You're going to shift it left like I show here, or you're going to shift it right like I show here. You're going to shift it something like this. I want a demand curve graph that looks like this. PQ, D1, D2, P1 doesn't change. QD1 will either increase to QD2 or decrease to QD2, etc., etc. Again, office hours are 10 to 12. And I want it for the rest of this too. I want you to tell me what happens to the demand for fresh grapes if low-fat diets grow in popularity. What will happen to the demand itself? And over here, I said over here, you're going to tell me what's the relationship. And here you have them to choose from, as you do on page 42, 43, 44 in your textbook. What happens to demand for hotel rooms near Disney World if Disney World increases its prices? What's the relationship? What will the demand curve do? Increase, decrease. You'll graph it, again, with a nice big L, down slope, all that. Okay? That's your homework. You're probably not going to use this because it just doesn't work so great. It really doesn't. It's kind of small. But if you can squeeze it in there and take a nice picture scan of it and email it to me, that'll be fine. So all I need here is a letter. One of these 6 letters. You put one of them in there. You can write the term if you like. Either one is fine. That's page 25 homework. If you have questions or comments, please see me before or after school. Yeah, I know. Between 10 and 12, Monday through Friday on Zoom. I will email you an invite. Check for it then. Ladies and gentlemen, that's it. Shifters of Demand. I'm out.